Welcome to qnawire.
In this problem, we're driving in our car and we are locking our brakes so that the only force acting on the car in the x direction is the force of friction, which is slowing us down. So the complete force diagram looks something like this. If we apply Newton's second law in the y direction, we know it's equal to 0. Since the acceleration is equal to 0, it's not going to jump up in the air. This yields immediately that the normal force is equal to m times g. Now we know the friction force is equal to the coefficient of kinetic friction times the normal force, and we just found that the normal force was mg. So we have that the friction force looks like this. Now we can apply Newton's second law in the x direction. In this case, we can't set it equal to 0 since we're accelerating in the x direction. In this case, we get negative mu k mg, our friction force here. It's negative because I define my coordinate system like this, and it's moving in the force is in the negative x direction. It's equal to mass times acceleration in the x direction. The mass cancels out, and we, after plugging in, get that the acceleration in the x direction is negative 7.84. And it should be negative because since the force of friction is in the negative, we're going to be accelerating in the negative. Now that we have the acceleration, we can use a kinematic equation in order to solve for the distance traveled. We know that the initial velocity is 28.7. I'm suppressing units for now because they're all in meters and seconds and kilograms. Our acceleration we just found was negative 7.84. Our final velocity will be 0. It'll be at rest. And our unknown is x minus x naught. And so we're going to use v squared is equal to v naught squared plus 2a x minus x naught, just one of the kinematic equations. And when we solve for x minus x naught by plugging in our knowns, we get that it's 52.53 meters needed to stop. Now for part B, we want to figure out how fast we need to move with a different coefficient of kinetic friction so that we stop in the same distance. Now in this case, our kinetic coefficient is 0.25, so it's much less because the road's now wet. If we follow the same process that we did in part A, we can find our new acceleration, which is negative 2.45. Notice it's much smaller now. And now our knowns are x minus x naught is 52.53. We want to stop in the same distance, so I'm just borrowing the answer to part A. We're trying to solve for our initial velocity. Our final velocity is still 0, and our acceleration is sitting here. We're going to use the same kinematic equation, but we're just going to solve for something else. In this case, we're solving for v naught. When we do that, we get that v naught is 16.04 meters per second. And that's the problem completed.